speaking to you today actually from France, because I'm actually on a cycling holiday at the moment. So I've called in some friends for a few days so that I can use their Wi-Fi to give this presentation. As was noted, I'm going to look at really the last 3 decades of mostly focusing on mitigation, on reducing our emissions, in line with our commitments that we've made at the Paris, particularly in the Paris Agreement in 2015, but obviously the repeated COP since then, and the Glasgow COP in November of last year. I'll be brutally honest, and my focus primarily is on the global north, and that's because that's where on mitigation, that's in terms of emissions, that's where the principal failure has been. And that's not to say there aren't some significant challenges and requirements of the global south, but let's not pretend any other way than to say that it's the global north that has knowingly chosen to fail on climate change for at least 3 decades. And clearly, in addition to that, now has been the rapid rise in emissions from China, which really needs to be a focus of attention as well, because it now dominates much of the global sort of landscape in terms of mitigation. But my focus primarily is on the global north. But of course, that has significant repercussions for the global south. And I'll come back to that right at the end of this talk. But I want to start just by reminding us about the Paris Climate Agreement, which was in 2015, at the end of 2015. And the Paris document, which is well worth reading, it's not very long, but it makes the point that virtually every country in the world has signed up to reduce emissions in line with holding global temperature rises to less than well below 2 degrees centigrade, and ideally aim for 1.5. It also agreed that it would do this in accordance with the best science, and very importantly, in my view, on the basis of equity. And that has been completely ignored. There's been a little bit of lip service to it, but nothing serious from any part of the world, particularly the wealthy parts of the world, in relation to equity between the poorer and the wealthy countries, but also, of course, equity within countries. And I'll come back to that later. But because we've signed the Paris Agreement, I want to sort of start by really evoking the spirit of JFK, sort of abusing his comment from years ago. And the question is really not what can countries do to reduce their emissions, but actually what total reductions does Paris require of their country? You know, we shouldn't sign something, we shouldn't promise to do something if we cannot deliver on it. And so I repeatedly hear, oh, this is the best that we can do. Well, the best is usually not good enough, and we must do much better than that. We shouldn't have signed it if we don't think we can commit to it. And so I take it that, well, we start off from our commitments and then we work out to what we need to do rather than the other way around. Now, I want to just think about 2 other crises first, 2 other emergencies, and use those to frame some of my discussion today. One is the banking crisis. Now, I don't know how old all of you are, but some of you of my age will remember the banking crisis, and it was pretty much a global banking crisis in many respects anyway. Certainly it hit the global north, but also quite a lot of the global south, and certainly lots of Asian countries were severely impacted by it. So if in 2006 you said we want rapid social change, you'd be told by lots of experts that's impossible, the public will never accept it. Yet in 2007 we had this huge subprime mortgage scandal in the US rather, which triggered this global banking crisis. We had a decade of austerity policies that are still hitting the poorest communities in many parts of the global north. And I will not make any sort of colonial comments about me knowing anything about the global south. I really don't. And that's why I tend to steer away from making any detailed comments about the global south, because people like me have done that for years from a position of ignorance. So I try to avoid that. So, you know, austerity has really hit the poorest communities in the global north and continues to do so today. There were huge cuts in public services, massive job insecurity, massive social upheaval for many. But also overnight, what happened was the governments who always claimed they hadn't got any finance, they couldn't access finance. Overnight, they produced huge quantities of public money through a concept called quantitative easing. It's a financial mechanism by which you can suddenly mobilize, effectively print money and pump that into the economy to stimulate spending. Now, they could, of course, spend that on green stimulation to do things that were really important from a sustainability and an equity perspective. They didn't do that. Very few governments did. Chinese a little bit, Koreans a bit, most European and the US governments did not do that. But it does show that, did show that you could get social and financial change in 2 years. We managed to do it then, even though we were told it wasn't possible. Roll on to the COVID tragedy, which is still playing out across many parts of the world today. And again, in 2019, we'll be told that rapid social change is impossible. The public will never accept it. We have the COVID crisis that triggers a global response, certainly in the wealthier parts of the world. We saw this big lockdowns, rapid mobilization of science and tech, again, with equity not playing an important part there in terms of where the vaccines were distributed. Treatments of vaccines came out very rapidly. Again, we saw, rather like the banking crisis, we saw poorer key workers, communities being impacted most by COVID itself, particularly in the UK, and I know many other European countries, people of colour who were disproportionately impacted because they were, even within the wealthy parts of the world, they were typically people who had not done so well financially. But we again shifted from the impossible to the delivered in 2 years. So at a global level, when it's necessary, we can actually bring about rapid change. If we look at the COVID, the emission reductions at a global level that went along with COVID, they were about 4 to 5% reductions in carbon dioxide from energy. And if that level continued across the future from now, year on year, that would give us a very proximate sort of outside chance of 2 degrees centigrade of warming. So it gives you a flavor. Obviously, that's not how we want to do it, but it gives you a flavor of the sorts of scale of change in our energy use we would require if we were to hold to 2 degrees centigrade. But I think it's clear the signs are not good. We have not learned any energy lessons, emission lessons from COVID. The poorest and the wealthiest countries are still seeking ongoing economic growth, more energy, more resource use. This argument of decoupling, which is regularly used by academics and other policymakers, decoupling growth from emissions is just an appealing myth. If you look behind the facade, what you often find is they're just offshored the emissions to poorer parts of the world to produce our goods for us. Certainly, economic growth is to be welcomed in many of the poorer parts of the world. It's definitely what we want to see. And in fact, I would argue for myself, I want to see a rise in the emissions in the very near term for the poorer parts of the world, because that means they're using more energy and that's better for their well-being overall. But in the UK, the EU, the US, we have ever more economic growth. We're pursuing it now. Is enough ever enough? And if so, when? It doesn't appear to me that the economic realm has really dealt with this issue appropriately at all. It's always hidden away from this. At what point do we have sufficiency? Can you keep growing on a round planet? So bring this back to climate change. I want to just, this is going to sound quite flippant, but I want to just touch on a bit of science. I'll come back to some more science later, and just make it very clear that the climate does not respond to good intentions, to Machiavellian policies, to eloquent arguments, legal niceties, or accountancy scams. And we've been trying these on climate change for years. All of these are trumped by the brutal beauty of the physics. And what is absolutely clear, it is the total quantity of carbon dioxide, principally carbon dioxide, and other greenhouse gases that we dump in the atmosphere that relate to temperature and impacts. And all these other things out there don't matter. It's the physics that matters, not the scams. And we've been very good at scams for 30 years on this. So following on from the Paris Agreement, and particularly around the framing of 1.5 degrees centigrade, which was a real shock to many of us to see that in there. And I'm really pleased, even though I was quite critical of it at the time, in retrospect, I think it's been really important to stop the drift towards 3 and 4 degrees centigrade of warming, to help focus about, well, what do we need to do for something more severe, like more challenging, like 1.5. And the IPCC, the Intergovernmental Panel on Climate Change, has to look at this following Paris, and to summarize their report in just a couple of sentences. What was clear was the impacts of 1.5 degrees centigrade of warming are severe across ecosystems, across human systems, across physical infrastructure and agriculture. More floods, more droughts, more extinctions, and more human migration. So 1.5 is not a good threshold. It is not a safe threshold. but the impacts of 2 degrees centigrade are considerably worse. And I think that's a really important finding from that report, and indeed from the report just last year, the updated one in 2021, that the impacts for very small differences in temperature can actually be very significant. So it re-emphasizes how important it is that we mustn't go above 1.5, even though that looks incredibly challenging. And that led, at least rhetorically, to a lot of countries claiming climate emergencies. And then in 2021, we had the wealthy countries of the world come together in the G7 climate and produced the G7 climate communique, where they reinforced the argument about staying to 1.5 rather than 2 degrees centigrade. And that's because there was a recognition, and there's increasing recognition, the impacts look very severe at 1.5, even for the wealthy parts of the world. And then in COP26, we have, which was obviously in the UK, with the UK sort of framing it around the language of keep 1.5 degrees centigrade alive. And this is Patrick Vallance, who's the government's chief scientific advisor, saying this is not a negotiable thing. We have to aim at 1.5. We have to deliver on 1.5. So there's a lot of emphasis about shifting from 2 degrees centigrade to 1.5 because of the recognition of the impacts that will occur. So I want to now think about 1.5, and it's easy to use that language, you must stay below 1.5. What does that mean from a scientific point of view? We've got to convert it into some sort of probability to get a handle on what that might mean from a number point of view, which then can tell us what that means from a policy point of view. So one way of thinking about it is that you could think of it as a 50% chance of not exceeding 1.5, a 50-50 chance. Not great, but sort of okay. It could be a better chance. This is the probability that's used in the IPCC, a 67% to 100% chance of staying below 1.5. Or indeed, you could go for the Paris framing of about well below 2 degrees centigrade, and and see that as an 83% likelihood. I'm choosing those probabilities because they're the ones that are used in the IPCC reports. So I'm using their sort of numbers to understand this. Now, I want to focus most of this presentation on this sort of new framing, as I would see it, around a 50% likelihood of staying below 1.5. I mean, that still means there's a chance of 2. It still means there's a chance of 2.5 or 3 degrees centigrade, but obviously the probabilities of that are smaller. But let's also be clear that, to reiterate what I said before, 1.5 is not a safe threshold. We're locking in suffering at 1.5. For many poor people around the world today who are already suffering severe weather events that are exacerbated by the climate change that's being knowingly caused by the high emissions of particularly of the global north and increasingly of China as well. So many people are already suffering from climate change. It's already having severe impacts on ecosystems. This is an emblematic one here, the barrier reef, which at 1.5 degrees centigrade, the barrier reef and almost all tropical corals will be severely impacted. The barrier reef, by about 75% of it, probably killed. But at 2 degrees centigrade, there will probably be no tropical corals around the world. Some deep water corals, but not tropical corals. But obviously, this is also impacting future generations as well. So even 1.1 degrees centigrade is going to have impacts for other people. For many people today, climate change is not a threat. And this was pointed out to me by a lady from the Philippines in COP. I'd often referred to the language of climate change as a threat. And she very rightly told me it's not a threat, it's a reality to many people around the world. And I think I've had to rethink that. I mean, that's exactly what it is. It's not as if it's about the future. Climate change is about today. People are living and dying with it today. So that's only 1 to 1.2 degrees centigrade of warming so far. So what has been our response to these commitments that we've made? Well, to start off with, my generation, and I'm almost 60 now, so I'm 60 in 6 or 7 weeks' time. But my generation, and even the generation younger than me, we really need quite a bit of humility, because the first IPCC report, Intergovernmental Panel on Climate Change report, came out in 1990. That's almost 32 years ago. 32 years. Some of you listening to this now will probably not have been born, or your parents may not even have met that long ago. And yet in 2021, the emissions were over 60% higher than they were in 1990 and still rising. So what we have presided over, people of my generation, have presided over abject failure to reduce emissions for 31 years. Some of us may have tried, but let's be blunt about it. We have failed. And I think sometimes it's important to recognize that and just to reflect for a few moments before saying, well, how are we going to succeed from here? Just to remind ourselves that we've had a long legacy of failure. And of course, country after country says that it's demonstrating leadership, and nowhere is better at this than the UK, a country that excels in rhetoric. So the UK makes this wonderful claim that it's had big reductions. So in 2020, we're 50% reductions below 1990 levels. But if you include international aviation, you include our shipping, and you include our imports and exports. So we export some goods that we manufacture, but we of course import lots of others that other people manufacture. If you do that, then what you see is that the UK has demonstrated no real leadership, about a 15% reduction since 1990, less than 0.5% a year. And later on, I'll be showing that we need somewhere almost like heading towards 20% a year now for 1.5 degrees centigrade for the wealthy country. And that is true of Denmark, Sweden, France, and of the EU more generally. In the so-called progressive parts of the world, we have seen no real leadership in relation to the challenges that we have committed to in Paris. And if you look at other parts of the world, the US, Australia, Norway, and Canada, as wealthy parts of the world, you see massive increases in emissions since 1990. Obviously, you see that in China as well, but Chinese emissions are still much, much lower than any of those countries there per person, far lower, running at probably about 7 tons per person. These ones are more like, typically more like 16 tons. I think Norway's probably a bit lower than that, but the others are somewhere around 16 tons. So what's been the real response to Paris and the climate emergency? Well, we've seen no sweeping and rapid social change like we saw with the banking crisis or COVID. We've seen no immediate and widespread penetration of low carbon technologies, which we've seen, say, with the vaccine and so forth. What we've seen is more renewables, plus more oil, gas, and indeed more coal. We've seen some electric vehicles, plus more petrol and diesel cars. And we actually, if you look at the EU, it's selling now more sports utility vehicles than it is selling electric cars. We've seen some improvements in efficiency, plus more consumption. And let's remind ourselves, the climate does not care about renewables or efficiency or EVs. It only cares about carbon dioxide molecules. So we can't have these other things as well as oil and gas. We have to have them as a substitute to them. And that's what we have failed to do so far. But what we've now developed is this whole language of net zero, which in my view should be more like not zero, or I prefer to see net as being Latin for kick the can down the road. It's a way of broadly supporting incremental changes to business as usual. It's an incredibly dangerous framing of climate change. And I will come back to that later. So what does the IPCC tell us about Paris, about our commitments when we think about mitigation? Well, if you look at the reports from 2015 right the way through to the latest one last year and summarize them all, what they say is that it's the total carbon budget, not long-term targets that link to temperature. So what you do by 2050 or even 2030 in isolation is not important. What matters is the carbon budget. And to put that in some sort of stylistic terms, it's the area under the curve you can see here. So what we do by 2050 is of much less importance than what we do in the near term. And so if in the near term, we decide to expand our airports, increase our oil and gas production, drive further and so forth, then that passes a much greater burden onto future generations, a burden that I would argue would be impossible to deliver on. And that's why we have to do some really big things today. So that's the sort of carbon budget framing. And that's what the science tells us is required, that framing. So if we go to the latest set of reports from the IPCC, what referred to as Assessment Report 6, AR6. Unfortunately, climate change is full of acronyms, many of them very hard to follow. So Assessment Report 6, which is the latest report from the scientists on the sort of scientific body, if you like, on climate change. And it produces a nice little table like this within the report, which you can find within, I think it's table 2.2 in the report. And what it does, it says for a particular temperature, which is a temperature rise compared to the pre-industrial period before we started burning fossil fuels, from 2020, and of course we're now in 2022, but from 2020, it tells us for a given probability of that temperature, how much carbon dioxide we can dump in the atmosphere. So for a 50% chance of 1.5, we can dump 500 billion tons of carbon dioxide into the atmosphere. If we want a higher chance of not going above 1.5, then the amount of carbon dioxide is less at 400. If, however, we're prepared to accept a higher temperature, like 2 degrees centigrade, which obviously would be devastating for many parts of the world, then we have a bigger carbon budget. So more impacts, much more devastating impacts, but easier mitigation. And that's that compromise that we have all the time. And I'm going to try and focus mostly on the 1.5 now. So if we adjust those budgets to January 2022, and let's think we're now into May of 2022, so we're probably somewhere in the region of heading towards 10 tons or so, 10 billion tons of carbon dioxide have been emitted this year, somewhere like 10 billion tons, roughly this year. The global carbon budget for all carbon dioxide emissions from energy and from land use is about 420 billion tons that we can now emit for 50-50 chance of 1.5. We emit currently about 42 billion tons. So a quick bit of clear maths there tells you we have 10 years of current emissions. If we kept it a straight line from where we are today, in 10 years, we'll have used up all of that budget. But this year, emissions will probably be higher than they were last year. So currently we're not going in the right direction. Now, I want to update this to 2022 and for energy only, which is the focus I have, which is mostly related about fossil fuel use. So there's land use issues as well, and some other industry issues, but I'm focusing here mostly on energy. And so to convert all that language of probabilities into sort of a more day-to-day wording of it, if we want a goodish chance of 1.5, then we know we can dump about 260 billion tons of CO2 in the atmosphere. If we want an okay chance of 1.5, it's 50-50 chance, then we can dump from energy 360 billion tons, and for 2 degrees centigrade, more like 680. But I think just to give us some flavor of that, for a good chance of 1.5, then we're talking about 7 years of current emissions. As I said before, about 10 years for a 50-50 chance, and about 18 years for not exceeding 2 degrees centigrade. So these are really, really tight timeframes. This is assuming it just carries on a straight line. But if, of course, we bring emissions down, then we have a bit longer. That's what I'm going to look at today, next here. So this is a good chance of 1.5, worth 2 degrees centigrade. You see a emission curve broadly like this, but we've got to start reducing quite quickly. And this is a global level. Remember, this is global energy only. If we then look at one for a good chance of 1.5, look how much tighter that is, how much steeper that becomes. And even for a 50-50 chance of 1.5, then it's incredibly tight. And I want to really focus more on that. And then remember, this is at a global level. So if you can look at that rate of reduction there, it's just phenomenally fast. So we're looking there at somewhere around about 2040 at a global level to get emissions to zero, somewhere around about 2040. So that's zero fossil fuel use by 2040, which is just 18 years from today. So I now want to focus on mitigation, on what we have to actually try and do about this, and again, focusing on this 50% chance of 1.5. So one way of thinking this is that we have this big global carbon pie that we have to split up between every part of the world. And we know roughly how big that is for energy, about 360 billion tons of CO2. But the Paris Agreement and every agreement from 1992 onwards has said that we need to reduce emissions on the basis of equity. There's another awful acronym called CBDR, Common but Differentiated Responsibility. And that's basically, it's an agreement from 1992 onwards that the wealthy countries will show leadership and will reduce emissions ahead of the poorer countries. Now, the poor countries will have to do quite a lot, but the wealthy countries should be demonstrating some leadership on this. And the language in the Paris Agreement uses developing country parties and developed country parties, basically wealthier and poorer countries. But the poorer group here, developing, does include China, and it includes places like Rwanda. So there's a big difference within that grouping. But this is using the language of the Paris Agreement. And so in some work that colleagues and I have done over the last couple of years, we've looked at this sort of developed and developing country party groups in a bit of detail. And for an okay chance of 1.5, if you split the two up, and this is based on some work that I did with colleagues that was published, I think about a year and a half ago now, and I can afterwards pass a link onto that and one or two other papers. They're deliberately made open access, so anyone can see the paper for free. But what we did there was initially to look at developed and developing countries. And what you see here is that for a reasonable chance of 1.5, then the rich countries have to be zero emissions by about 2030 to 2035. Now, that is massively challenging. And the poorer countries have a little bit later, till the 2040s. So it's really it tells you quite a lot about how rapidly these changes need to be brought about. So how are we doing now? If we use that as the framework between richer and poorer countries. Now, I'm going to just touch on this briefly here. I want to ask, how are the wealthy countries doing and what would their role look like? But I also want to take out of that this idea of, I've called it here generational buck passing, which is where we pass the burden on to future generations to develop technologies to remove carbon dioxide from the atmosphere. And I'll come back to that later, but that is a really major part of all of the scenarios, of all the policy framings of the wealthy parts of the world now, that they're relying on future generations to suck our carbon dioxide out of the atmosphere. And we're also relying on poorer nations to make cuts for us through a concept of offsetting or a clean development mechanism. So the wealthy countries, again, are passing the burden generationally and to other parts of the world today. So I'm taking those out, not including those, and asking the question, for a developed country, how big is our carbon budget? And I'm going to use again here the UK as an example. Now, the UK is probably quite typical here, but it claims to be leading on this amongst the wealthy countries. And I'll come back to this as why this is important for the continent of Africa, for the countries of Africa towards the end. So this is our assessment here, provisionally for 1.5 and 2 degrees centigrade. So the carbon budget the UK can emit is about 3.5 billion tonnes. That's about 9 years of current emissions for the UK, about 10%, over 10% per annum reduction rate, and zero emissions for 2039. But for 1.5, the budget gets much smaller, 1.7 billion tonnes, just 4 years of current emissions, about 19 or 20% roughly reductions in emissions for the UK, and 2031 would be the zero carbon date. Now that would be true for Sweden. It would be very true, probably slightly quicker for the US and Canada, a bit slower for Poland or Hungary, someone's from today. Some of the slightly poorer, some of the Portugal and Italy would be a bit lower, a bit longer. So the poorer of the wealthy countries have a little bit longer, and the wealthy countries of the wealthy group would have to be do it a little bit sooner. So again, there's an equity part there. But that's in stark contrast to the UK government's position, which is roughly a 5% per annum mitigation rate, and they claim that's in line with 1.5, not the nearer 20% we'd require. It has net zero by 2050, not real zero by 2035. And even in 2050, if you look at the spreadsheets that underpin the government's policies, it's still got 31 million tonnes of carbon dioxide being emitted in 2050. That's more emissions in 2050 than Kenya has today from the UK, from burning fossil fuels. And it intends to burn the fossil fuels well after 2050. So always look at the spreadsheets and look at the scams that are embedded in them. The carbon budget is over 6 billion tonnes for the UK. If you worked it out from their spreadsheet for the government, that's 3.5 times bigger than roughly 3.5 times bigger than the one for 1.5 degrees centigrade. So the UK government position is more in line with 2.5 to 3 degrees centigrade of warming than 1.5 to 2 degrees. And the UK is ahead of many other wealthy countries. So let's be clear, the wealthy countries are choosing actively to fail. If we are going to meet 1.5, we need to treat it like the emergency is. 19% per annum mitigation, thereabouts, zero carbon transport by the early 2030s. And that's immediate and profound system change, much more in line with the banking crisis and COVID than the sorts of weak policies we've been seeing so far. Now, why is all of this so different to the net zero framing that we typically hear, net zero 45, say for Sweden, or net zero for 50 for the UK and some of the other wealthy parts of the world? So why is it so different? Well, firstly, this net zero framing, which some of you hopefully are familiar with, and it's now almost used without people thinking about it, but it's a new phrase. In the IPCC 2018, it was used 16 times in the summary for policymakers, but it wasn't used once in the previous report. So in 2014, it wasn't used at all. In the UK government's advisory body on climate change in their report in 2020 to the government, it was used between 3,000 and 5,000 times, and yet in their report in 2015, it wasn't used once. And so this language of net zero has been really helpful, because it's like, what it really means is not really zero. That's what we mean by it. And that everyone can get behind not really zero. It's attractive to everyone. Net zero is typically not based on a carbon budget framework, so it doesn't have a lot of science behind it a lot of the time. It focuses on these far off dates when the policymakers will either be dead or retired somewhere. And indeed, so a lot of the senior professors and academics who are behind it as well will have been retired or will be dead. So we're passing the burden on to other generations through this language of net zero by a long time from today, net zero by not in my term of office. I think of it from a policy point of view. It also embeds some really dangerous forms of substitution between greenhouse gases, between carbon dioxide and methane. These are very different gases with different lifetimes and different chemistries, between different sources. So carbon dioxide from burning fossil fuels in a car compared with nitrous oxide and N2O emissions from fertilizer. So these again are different sources with different risk factors, but also it allows us to substitute between decades. So a flight today can be claimed to be offset by capturing the carbon in trees that grow in 2070. It assumes that a ton is a ton of carbon dioxide, regardless of different chemistries, regardless of different atmospheric times in the atmosphere, with some of the greenhouse gases lasting for decades, if not centuries, other ones just for shorter periods of time, and ignores levels of certainty and risk associated with these different gases from different sources over different timeframes. It allows the policymakers to always tweak things to make it as easy as possible for us today. But it also embeds, and I touched on this earlier, this concept of negative emissions or carbon dioxide removal, either through technologies that barely exist today, just using small pilot schemes, or so-called and attractive sounding nature-based solutions. And just to give a sense of how important these are, almost all of the scenarios in the IPCC Working Group 3, which is focused on mitigation, almost all of them assume hundreds of billions of tons of carbon dioxide removal by future generations, most of it after 2050 and going on beyond the end of the century. And that allows us to carry on expanding airports and driving and living high carbon lifestyles today. And to give a flavor of how big that is, that's an industry that we assume will exist in the future to remove CO2 that's roughly the same size, very approximately, as the current oil and gas industry. And almost every scenario assumes that will be the case. We have normalized the idea that an industry that does not exist today will exist in the future to make things easier for us today. Incredibly dangerous. It is a systemic bias across those of us who work on climate change. Remember, these technologies at best are in small pilot schemes collecting a few thousand tons, maybe the odd million ton, not the billions of tons that are assumed in the scenarios. My position on carbon dioxide removal is, yes, it's important from a research point of view. We should deploy it if it meets sustainability criteria, and that's ecological as well as, social as well as ecological criteria. But let's reduce our emissions today, assuming it will not work at scale, because it probably won't do. But we're already using it to reduce our mitigation. And of course, some carbon dioxide removal will be required to compensate for emissions from agriculture that cannot be eliminated. You cannot eliminate all of the greenhouse gases from agriculture, but you can eliminate them all from energy. And that's why energy needs to be real zero, not net zero. For a lot of people, net zero seems to be attractive because it's a framework that allows everyone to get involved, and that's its strength. But some people argue that, in my view, it's that vagueness that is actually undermining the need for immediate and deep cuts today. And I think that is really evident when you look at the scenarios on this. Put simply, again, this is my view, that net zero hides our relative inaction. It sort of allows us to think of large but incremental change to business as usual as being in line with Paris, when actually business as usual cannot be aligned with Paris anymore, nothing like it. So I think it's a scam in that respect. I did talk about this with some colleagues a few years ago, and I'll pass on this link later. But just to take a quote from an article we wrote that was based on the paper, this is what net zero embeds. The UK government approved North Sea oil new North Sea oil fields and presides over airport expansion. The EU ignores climate science and embraces gas as a transition fuel and sees the sales of sports utility vehicles, very inefficient cars, soar to a record high. Across the Atlantic, Biden spends $25 billion of federal funds on new airport development and oversees a rise in emissions in the US, already very high emissions, of 6% in 2021. 3 months on from COP26, there are declarations of climate emergencies now de rigueur, with Exxon and Saudi Arabia joining the net zero choir. And yet in 2022, emissions are set to rise again. So net zero, even when emissions are rising, allows Saudi, Exxon, the US, the UK, the EU, all of the high emitting countries can pretend they're doing something behind this language of net zero. So I want to start kind of putting all this together now, but just to reiterate the importance of equity in all of this in climate change. I would argue, regardless of our moral or political position, Paris plus the Intergovernmental Panel on Climate Change equals equity. Equity is not a nice to have, it's absolute prerequisite of meeting our commitments. You cannot squeeze emissions out of people that do not emit. And carbon dioxide emissions are highly skewed towards the few. So here's a little plot. This is from 2015, but it's been reiterated just in the last year by some really interesting work by Sivan Carther and others, whereby it shows the emissions from the wealthy people around the world. And some of those, of course, are in the poorer countries, dominate the emissions at a global level. So 50% of global carbon dioxide emissions come from 10% of the population. 70% of emissions from just 20% of the population. And I think most damning of all is the top 1% of global emitters have a carbon footprint that is twice that of the bottom 50% of the globe. And you think, who's in that top 1%? Well, most professors are in it. And so we really have to start to think about our role in that 1% and indeed in 10%. And I think that figure is worth reiterating. The top 1% of global emitters have a combined carbon footprint that is twice as high as the bottom 50%. And we're supposed to be in a climate emergency. Does this really matter? Well, a quick thought experiment, I think, is helpful here. Let's imagine we thought climate change was a threat, and shouldn't use that word threat, is a reality, and we felt we should do something about it. Let's imagine we put in regulations in all the countries of the world to require the top 10% of emitters in that country to cut their level of CO2 to that of the average European. So not a really low level, still quite a high level. And the other 90% of the world's population make no change. Now that would actually bring about a 1/3 cut in global CO2. Not enough for 1.5 or 2 degrees centigrade, but a huge start and far more than is ever promised at any COP. So way above that. And that's just 10% of the population, the high emitters, reducing to the level of the average European. Imagine if they reduced to the level of the average Kenyan. That would be, that would start to be an even bigger cut in emissions. So to bring all of this together, the headline choice for developed countries is we can either ignore international equity, we can pass a huge burden onto our children and onto children in other parts of the world. We can be part of a 2.5 to 3 degrees centigrade future with all the massive climate repercussions that would have. And we can renege on our Paris and G7 commitments. But that allows us to dovetail with today's politics. So it fits nicely with current politics. It fits nicely with the current market model. It gives us about 5% mitigation rate and some sort of net zero by 2050. But if we were to take international equity seriously, then that would require a huge mitigation effort by this generation to cut emissions in line with 1.5 and to meet our G7 and Paris commitments. But that would need a huge ramp up in government leadership and intervention, a reshaping of mainstream economics. To some extent that's happened or is happening with COVID and indeed the banking crisis, but not in a positive way in my view. And it would need to have equity at its core. And that's 10 to 20% mitigation for the wealthy countries and real zero emissions by about 2035. Very different to the other one. Delivering on Paris and indeed on G7 means we have to ask some questions about what constitutes growth, progress and development. It's quite fundamental philosophical questions we have to start to ask ourselves. How do we frame value and reward success During COVID, we recognized, at least in many of the industrialized countries, we recognized the value of what were called key workers. We clapped for them, we banged pans for them in the UK on a Thursday, and we sang songs for them. We didn't pay them, of course. These were typically the poorer people in our society. And we started to realize that they are the people who actually have real value. And yet, who do we pay well? We pay the professors, the stars, the business people. We don't pay the key workers. So we need to re-question value and success. We need to have a better relationship with time. We've always had a poor relationship with time. We're always obsessed by the present. And in that sense, we need to embed our concerns about intergenerational equity, thinking about other people elsewhere in the world today, and intergenerational equity, thinking about our own children and their futures. And we also have to have, I think, a much deeper appreciation of the more than human world, of which we are part. We can't survive on this planet without working in harmony with the rest of the natural world. And I think we've always thought ourselves, we've increasingly thought ourselves as somehow abstract from it and above it, but we're actually very much part of it. And so I think we need to rethink all of those things and do it very rapidly. And a final sort of thought for African nations, and this is my only real comment in relation to African nations, because I really don't want to perpetuate that colonial spirit that the UK has successfully done for a long time. And so I don't know very much about Africa, but I would suggest getting your own house in order, being guided by equity in terms of emissions is really important. And there's obviously a huge difference in Africa. I think South Africa is about 8 tons per person. Kenya runs about 0.3, Rwanda about 0.1 of carbon dioxide per person. So there are very big differences in terms of emissions across Africa. But at the same time, and I think this is my key message, the bit I do know a bit about, is that you need to put all the pressure you can on the wealthy, high-emitting nations. Do not trust them. Do not trust us. Check our numbers. Read our spreadsheets. Look out for scams like offsetting carbon dioxide removal. We are doing everything we can to pass the burden on to our own children and to the poorer parts of the world. Look carefully behind our headlines and our eloquent speeches, because that's all they are. They are just rhetoric so far. There is no reality behind them. And don't argue over the $100 billion that's been claimed. Actually, the wealthy countries haven't even delivered on yet. That's to help some of the poorer countries deal with the impacts of climate change. The $100 billion is a crumb that's fallen off our rich person's table. And the trick is to have other parts of the world argue over it. You should be demanding the trillions of dollars that I would argue are owed to the poor parts of the world. First, for reparation, because what we have done is damaged your prospects. 2 things: we've damaged your environment, and we are damaging that today in terms of the impacts of climate change. But we're also damaging your prospects for doing something about for development in the near term by requesting that you don't use fossil fuels, that you leapfrog the fossil fuels. So there are 2 elements there. One, to deal with the impacts of climate change through, I would argue, reparation. And the second one is to deal with leapfrogging over climate change to a zero carbon or low carbon future. And that will not be cheap. The $100 billion is a joke. You need to be thinking about the trillions. So my final slide then is that in 2022, climate change has become system change. As Einstein noted, insanity is doing the same thing over and over again and expecting a different result. And thus far, we've chosen to pass on to our own children the consequences of 31 years of such insanity. And I would argue net zero by 2050 or 2045 or 2060 for India is the latest incarnation of that insanity. So we need to think, we need to be doing far more than any of the rhetoric we ever hear at the COPs. So on that note, thanks very much for listening.
Hi, everyone. Kevin, I just want to say thank you for your very, very interesting talk and presentation. I particularly liked how you said, climate change does not care; it cares about the CO2 emissions, and I thought that was a very important thing for me to hear. As somebody who doesn't know much about climate change besides everyday things that are going on, and the emphasis on people in Africa or states in Africa putting pressure on the wealthy, on the more developed countries. and what their role is in reducing these emissions. So I think on behalf of Cheers Africa, the students and everybody else here, I think we all learned something. We've got some really important things to think about, because I think as we hear about climate change, for most of us in Africa, it's always about what our role is and never what the role of the developing countries is. And we never think about that. So I think for me as a student also, it's been interesting to hear that. And it's definitely something else to think about. So thank you.
And now we come to the question and answer session of the program. Just a reminder that you can use the reactions at the bottom of the screen to raise your hand. And if your camera is switched on, you can just raise your actual hand or wave and I'll recognize you. And if you'd like, you can also write your questions out in the chat and I'll read them out to Kevin during our session. And for the students, feel free to come close to the mic if you have any questions, and please state your name so that we know who's asking and who's asking the question, and Kevin can refer to you directly. So thank you so much. This was such an interesting talk, as Prudence has said, and I'm excited to hear the questions that people have. And the floor is now open.
Dr. Anderson, thank you very much for a brilliant talk. And this might seem like a simple or stupid question if you put it like that. But what do you think are the chances? And I love the fact that you used COVID as an example of how we can stand together. I mean, all the paperwork's there, and it's all there in name. But we just need to go out in action. What do you think are the actual odds for this happening? That we all come together and work together.
It's not a stupid question. I think it's a really important question to think about that. I mean, I've said before, and I'll say it again now. I think the chances are 95% will go to an expression I often use as hell in a handcart. We are going to head towards 3-4 degrees centigrade, all the utter chaos and social collapse that will cause. But that's not 100%. Now, I don't know whether it's 90 or 95%. It's just a sort of a sense that the greatest chances that we will fail. But the 5%, the bit that's left over, that isn't just a probability. That's up there. That's there for us to go and get. That is our choice. So we actually choose to fail. We could choose to succeed. At the moment, I see very little evidence of that. And in fact, one of the papers I'll give a link to does it try to sort of say, I think there has been some hope in the last few years, I think, that has emerged from civil society and from student bodies. And I think this is interesting. It has not come from the great and good. It has not come from the sort of the Davos set. It has not come from the professors. It's not come from the celebrities. It's not come from the leaders. It was at least triggered or catalyzed by a 15-year-old Swedish schoolgirl. And she just catalyzed it. I mean, she's not going to bring about change. I know Greta fairly well. She would say that. But she is there as a catalyst for others. And we've heard a lot of voices from young people, from grandparents, from some early career academics, from student bodies. And they have changed the tenor, the tone of the debate on climate change. And I think that has been key. It hasn't brought about policy change yet. But the more people that can get involved in that and undermine the sort of elite structures of our society, which have failed on climate change, and I think have chose to fail, then the better the chances of that 5%. So I don't think the chances are good of us succeeding, but if we don't try, we are guaranteed to fail. And if we do try, we might succeed. And it's such a severe issue that it's worth us trying for everything we can.
I completely agree. Thank you very much, Professor.
Okay.
Thank you for your question, Rowan. We have another question from Tawani.
Hi, Professor. I was taking actually a class in climate change and adaptation this semester, and I have to now write an essay about climate change and adaptation within my country, which is South Africa. And I was wondering if you could maybe give me some advice of like key points to look at when I'm writing about that. I know you don't deal with the South that much, but yeah.
And also I think you probably know much more about that than I would. But I think just one thing to bear in mind, it's adaptation to what? And I have quite a lot of colleagues who work on adaptation, and they talk about it almost without thinking about what they're adapting to, because adapting to 1.5 degrees centigrade of warming and how that plays out in South Africa is very different to adapting to 4 degrees. And so I think you have to say, when you're thinking about adaptation, you have to think about the risks, almost like related to the last question. If you put in policies to adapt your water system, your sewage system, your energy system for 2 degrees centigrade of warming, and then you get 4 degrees centigrade of warming, then you probably have maladapted your system. You probably make it much worse for the citizens. So are you better spending a lot more money, which is obviously a risk, of adapting to, say, the equivalent of 4 degrees centigrade of warming, because that's a possibility. But that will cost you more money. But then if you only get 2 degrees centigrade, some people say, well, you wasted your money. So adaptation is not in isolation from what you're adapting to. And I think it is really important for the adaptation community to think about that. What are the local impacts of 4 degrees centigrade of warming across South Africa? What are the best estimates you have of that? And adapting to that seems the wisest thing to me, because I think the chances at the moment are we won't hold to 1.5 degrees. Now, we should still try to, but for the adaptation people, I think it's worth thinking about that risk issue. What happens if you get these higher temperatures? And I think an adaptation, that is key. You know, what do we have to adapt to? There's I can't remember which university is at now. Mark New, who's now based in South Africa, I used to work with him over here years ago in the UK. He did do quite a lot of work on adaptation a long time ago related to Africa. So it might be worth chasing him up. I've got a feeling he was based in Johannesburg, but I can't remember. If you put Mark New into Google South Africa, someone will know him. And he did quite a lot of work on that. Now, whether he's still doing that, I don't know. I've lost touch with him in the last few years.
Thank you.
Okay.
Thank you so much, Tawani, for your question. We have a question from Andrew, and then I'll read the comments in the chat. Andrew?
Thanks very much, Prof, for this enlightening presentation. My only concern is one. There has been assessment reports on different IPCCs from, I don't know, maybe 2001, 1999 and so forth until today. There is the IR6 that has come out now, and which still addresses the issues of COP21 in Paris. Now, my point is, what's wrong with humankind? What's wrong with us human beings? We keep writing IPCC's AR reports, and nothing is being done. Maybe now we're looking at AR7, I don't know, which will still address issues that were taken care of on previous IPCCs. So what is your assessment? What do you think is happening here? What is holding countries back from doing what needs to be done?
Yeah. Well, I think if we had that answer, then we would be moving in the right direction. We don't really know. And I always referred to earlier, there's a paper that we've recently had published just last year, looking at the last 3 years of 3 decades of failed mitigation and trying to explain why. And ultimately, our view in the end was it's to do with power. That was our best conclusion that we could draw. And we went into quite a lot of detail in the paper about why that is. And I think the power structures of the globe have really benefited out of the use of fossil fuels, and will not see a benefit out of the shift away from both high levels of consumption and the use of fossil fuels. So we split. I don't want to go into too much detail here because it takes too long, but I recommend looking at the paper and at some of the articles we've written around it. But basically, we split the world, not the world, but we split into 3 groups. The first group was the Davos cluster that meet in the World Economic Forum.
Yes,
and
yes.
Actually that particular one, that has dominated the dialogue. That has set the economic framework about, it's all about growth and competition. And it's a framework which we think is completely incompatible with sustainability, and particularly with climate change. But unfortunately, it's been supported by a lot of senior academics. So there's a whole academic dialogue that broadly supports that framing. But I think increasingly there are early career academics who are very critical of, in fact, how academics have too easily joined this elite group. And I think the third group that we looked at, so there was like the enablers, the academics. The third group was civil society, which is where most of us live, of course. Most people are in that group. And civil society, I think, has been surprising in that some members of that, significant numbers of people now, are engaging on issues of climate change one way or another, and are starting to change the debate. And our hope here was that if we could get civil society and those academics who are not locked into the Davos elite, if you like, so a more open-minded, honest academics, if we get those in civil society together, then that would be a very powerful force for change. Because what we thought we had to change were the power structures that dominate our society. And we tried to detail that with a whole series of authors on the paper. So I'll put, if I get a chance, I'll put a link in on the talk here. If not, maybe afterwards, if there's somewhere I could post the links to the paper. It's open access. But I think your question is really key. And in my view, power structures and issues of philosophy and culture and are really important parts of that. It's not all about science and engineering anymore. It's much more about the policy and the politics.
Okay, thank you, Prof.
Okay.
Hi, Kevin. Thank you very much for the talk. I have one quick idea, which is, or it's a two-pronged idea that I think maybe would be useful to talk about in a more generic sense, maybe not today, but in the context of everything we've been talking about, which is to reframe equity with using two concepts. One is to distinguish between activities that are necessary, that are essentially part of our basic livelihoods, that are existential, and all the activities that are deemed optional, like buying a big car rather than a small one, if you, for example, live in a rural community and you need this. And of course, the boundary between these two would have to be part of a civil society dialogue or moral conversation. And then similarly, that we return to this idea that there are things in the world that are divisible, dividable, and that means that we can attribute monetary or economic value to them, while there are other things, like, for example, human life, that we consider to be indivisible and that are fundamentally invaluable. So they cannot be traded at no price at all. And this last point is what I think brings me a little bit to the question that is also the theme of this series of talks, which is rethinking conservation. Because if I look at conservation in Africa, it is essentially today funded by money from developed nations. That's where the money is coming from. But the fact that there is even money necessary results from this paradigm or this mantra, use it or lose it, which is that every square inch of the planet or every square inch of Africa somehow has economic value and has to prove this economic value in order to be even considered to be worthy of a use. And so what we end up with is that conservation is, at the end of the day, a discussion within the framework of use it or lose it. And personally, and some here already know this, I think we need a philosophical discussion which essentially distinguishes between what is valuable and what is invaluable. And if we don't do that, I don't think we will be able to resolve the questions you have raised.
Yeah, they're all fascinating points, and particularly the latter ones are ones that I touched on in quite a lot of depth, actually, my PhD many years ago. Given that I come from an engineering background, I found it fascinating that my analysis would take me more to these sorts of philosophical questions. On the first one, it's really this argument about need versus option, if you like, or sufficiency versus efficiency. There's a lot of work being done on that by, now I wish I could point to some African scholars, very ignorantly again, I typically know more European ones, Julia Steinberger, William Lamb, and other people like that, and Jason Hickel have done some really interesting work on this, because there is this, particularly, I mean, I think it's in many communities around the world, but driven by the sort of competitive ethos of that dominates our economics, that we're always trying to pursue more and more. And there is an argument there to say, well, what is a sufficient level? What is the level that's required for a good life? So what do we need for a good life? And anything above that is probably going to be infringing other people's access to a good life. So asking those questions and what those things look like, it's not easy ones to come up with, but we can certainly start to identify what things are not reasonable. That's easy to identify, I think. On the second one, I think you're absolutely spot on. We have a particular form of economics, and it's not the only form of economics, there are many others out there, but the near-classical market-based form of economics only sees value in something that you can put a price on. And that is incredibly dangerous. And I think in philosophy, it's a category mistake. So, I mean, using the old, the sort of tale from the Bible, I remember using this years ago about Judas, sold for whatever it was, 30 pieces of silver. Well, to an economist, you just got the price wrong. It should have been 90 pieces of silver or 1,000 pieces of silver. To a philosopher, it's a category mistake. You don't sell your friends. And I think that's, that is our problem, is that we think we can put a price to life. And remember, that is being done. Let's not hide this. That is being done in virtually all of the big climate models. They're using, not all of them, but many of them are using some sort of marginal cost system in there, which embeds all sorts of things and puts a value to them to make the models work, because the models are effectively market-based general equilibrium models. I think that is a huge problem. We have to move away from that. There's a large body of people, ecological economists, who think very differently to that. And there's quite a spread amongst them. And I think that way of thinking actually works quite well with what you're talking about here. So some of the work from some of the more far-thinking ecological modelers, I think, is far more aligned with what you're saying and the broader philosophical framing, where there are things that simply are priceless, are beyond price, and should not be priced. And what you're talking about in terms of conservation, that seems to me, a lot of that seems to fit into that category, that it shouldn't be some sort of thing that you put a price on it and therefore it can be traded, which of course is what neoclassical economists assume. Once you put a price on something, everything is tradable. A kilometer of rainforest is tradable with a car park. They're all interchangeable. Love for your children can be exchanged for something else. And once a price is there, all commodities are interchangeable. I think that's a fundamental philosophical mistake. And unfortunately, too many of our governments are dominated by that way of thinking and this concept of cost-benefit analysis, which I think is really problematic.
Thank you so much, Mark, for that enlightening question. Did someone want to say something? I thought I heard. No, okay, sorry. Yeah, thank you so much. It also got my brain moving as well. And in line with Dr. Enyang's question, I was just thinking, I had the question about what can then, countries or governments from the global south then do to leverage their needs or their needs with regard to the climate crisis, seeing as Mark has alluded to, that most of the donations or the money that comes into conservation for spaces, I mean conservation even in terms of forests for carbon credits, etc., come from the global north. Is there something that you could recommend to countries from the global south, specifically, let's say in Africa, for governments to use as leverage for themselves in terms of negotiating their place in terms of the climate crisis and their needs in terms of the climate crisis? Because with specific countries, particularly the US, they can, sign, certain climate agreements or decide, they don't want to adhere to those regulations anymore, and they can come in and out. But for countries in the global south, that's not a privilege that we have, or
no,
something that we can do. Is there something, I don't know, you could advise, or any comments on that?
And that's in comment. I mean, I think probably the global south governments know how slippy the people are that they're having to negotiate with better than I would. I mean, going back to the last point, I think there is a concern about accepting money on the basis of some sort of value, because once you've gone down that route, it's very hard to move away from it. So I personally think, although in the very short term, it might make it more challenging, I think sticking to the sort of the values and principles is more important than say, well, instrumentally, we can do something which will help us get some money in the short term. Once you've done that, you've locked yourself into a way that means you're always trying to use that argument, or what's the value of this? Can we make some argument for why we need some more money? And this is my point about reparation, is that to me, the money that is owed to poorer parts of the world is because the damage has been knowingly done to them, at least since 1990. The first report of the IPCC was out in 1990. And the global north has done nothing about climate change. It hasn't reduced its emissions in that time. And therefore, there was an argument to say, well, you knew you were going to cause this damage. Your own scientists told you were going to cause this damage from 1990, and you signed up to common but differentiated responsibility, and you've done nothing about it. And so we should be looking at arguments of reparation rather than ones of, oh, you need to use this forest as a carbon credit so you can carry on driving your large vehicles in the States or in Canada or in the UK. I think going down that sort of market route is incredibly dangerous, and I think will fail in the end. And remember, every time a forest is protected because of some carbon credits, it's not really protected, because those carbon credits are being used as an excuse for ongoing high emissions in the global north, which will ultimately destroy the forest. And so it isn't protecting the forest, it's destroying the forest. And so I think principles and integrity and cogent arguments always win out in the medium to long term, but they're more challenging in the short term. And your governments have to be principled as well. I mean, let's not pretend that Western governments have been terrible. Global North governments have been terrible on climate change, but a lot of poorer country governments haven't been particularly good either not just on climate change, many other things as well.
No, you're absolutely right. Actually, my next point was, why is it that we keep electing politicians who don't understand, what's going on, instead of actual scientists? I wonder, why don't scientists run for office? Because it seems like the scientists are saying one thing and the politicians are just not listening. And so there's a gap, between policy and science, which needs to be filled.
Yeah, I'm slightly less in agreement. Scientists and engineers and governments should be made up of a mixture of people from different backgrounds, of which science and engineering is certainly one. But the last thing I would want is our scientists and engineers making our policies. And I'm saying that as an engineer, in isolation. I think it's really important to have a full range of people from the arts and humanities and and every walk of life in there making those decisions. And also, let's be clear that there's a difference between the scientists that work on climate science, understanding it, like the physics and the chemistry, and the scientists and the engineers and the economists, dominated by economists, who work on what we should do about it. And that group are actually, I think, are partly responsible for why we're failing. I call them mitigation deniers. They don't deny the science. I mean, they've often worked on the science, but they deny the fact is that science requires significant changes to how we live our lives to reduce our emissions. And they don't like that, because most of us, let's be clear, most of us academics, we live high carbon lifestyles. We have normalized in our own life ways of living that are completely and utterly unsustainable. I have colleagues who are really good in their climate field, who've bought second homes, who still regularly fly all over the world, who live very high carbon, high energy use, high resource use lifestyles. And asking them what we should do about these things, I think, is problematic, because they have locked in their norms, our norms. And so don't look to the scientists and the engineers necessarily to tell us what we should be doing about climate change. They can be part of the problem as well, I think.
So it's more of an interdisciplinary process, basically.
It is, yeah, and it needs to move outside of just the academic realm as well. Academia is a high carbon activity, increasingly dominated by competition, all fighting for students. Field works that we have, we always have to claim that to do field work all over the place with high emissions associated with that. The whole thing is a growth model. Every university is trying to grow, get more students. It's part of the dominant competitive growth model that is part of the problem. And so don't just look to academia, because it's not got all the solutions. It's also part of the problem.
Very sobering, but thank you so much for this, for answering that question. We have a comment from Sheila from Kenya, and she says, I think we need to craft messages to in the local language so that our communities can grasp these concepts. And I think, yes, that's definitely necessary. And Cedric is asking, will there be a recording to share? And yes, there will be. It'll be on YouTube, Cedric. And you can also check on the website Share Screen Africa for previous recordings of the Rethinking Conservation Series. Johan?
Could I just say on that, you're just very quick on that, come back on that comment from Sheila about the local communities. I also think that has to be two-way. There are things that we can learn from those local communities. It is not just about us communicating messages to them. It's about them communicating messages to us. They might be able to give us some ideas about how to live a good life that's low emissions, that's low resource use. So it's a two-way process. Sorry.
That was a good comment. Thanks, Kevin. Kevin, practical question to you. In terms of the technologies that are included in the IPCC forecasts, if we're looking at these net zero targets for 2050, what technologies are envisioned to, and do these technologies at least exist, or are these also technologies that are sort of hopefully going to exist in the future? And are there current technologies that one can rather look at to start considering more seriously?
Yeah, well, in terms of the negative emission technologies, there's two main types of technology. The first one, and it's the one that dominates the models, and as far as I'm concerned, it's just a deep embarrassment from an engineering perspective, and that's called BECCS, biomass energy with carbon capture and storage. So we grow plants, trees and other plant material, then we burn them in power stations to get energy out of them. We capture the carbon dioxide, and then we bury the carbon dioxide deep underground somewhere. And so the carbon dioxide is absorbed as the plant grows. We burn it to get energy, and then we bury the CO2. It is incredibly inefficient. Yet this is the one that dominates the models because it's easy to comprehend in your head, but it's awash with problems. I mean, not least the amount of biomass you require. 2 to 3 times the size of India is typically, as a land area, is typically embedded in the models. But also, for the modeler's perspective, they forget the fact is that plants grow on soils. Soils are very complex things. And in fact, in playing with the soils and doing things with the soils, you might release more emissions from the soils than you actually gain from growing trees and other plant material. It's also very inefficient to burn. I mean, plants do not contain a lot of energy, so you require huge quantities of them to burn it, and that process of burning them is incredibly inefficient. And then on the back end of that, you bolt on a big system to remove the carbon dioxide, which itself is going to add a big energy penalty. So from an engineering perspective, I think it's a deep embarrassment. If I was James Watt, I would be turning in my grave to think that in 2022, we're thinking about burning plants and burying CO2 as the pinnacle of engineering is a deep embarrassment to my profession. But that is the one that dominates the models because it's easy to model. You just ignore all the complexities and you just think, I get X number of tons of trees, that's so many tons of carbon dioxide. I burn it, I get Y number of kilowatt hours of energy, and I get T tons of carbon dioxide I can dump in the atmosphere. Nice in the model, easy to work, utter rubbish. A more hopeful route with, I think, other problems is direct air capture. And that's basically where you use some sort of catalyst, some sort of chemical catalyst. And there are some of these already available. And you run air through the catalyst effectively, and that absorbs the carbon dioxide from the atmosphere. And then you can get the carbon dioxide out of the catalyst, and then you can almost liquefy it. Again, you store it underground. From an engineering perspective, it's more attractive, but it requires huge quantities of energy. And we don't have huge surplus quantities of low carbon energy to put into this. If we did, we would be using them for driving our cars, for running our industry, for keeping our school lights on, for running our hospitals. You know, we're using lots of fossil fuels. So until we have surplus renewable energy or very large quantities of renewable energy, I think that is slightly misguided. But nevertheless, I think from an engineering point of view, I'm pleased to see research being done in that. And hopefully it can be made much more efficient. And maybe it's something we can start to use. And certainly there are some small pilot schemes that can now capture a few thousand tons. Some might claim up to 1 million, but I mean, all the capture so far has been very, very little from these things. They're just playing with them at the moment. They're either in the minds of an academic, or there are small pilot schemes. That's all we have. There are no big scale versions of these anywhere in the world. So I think that direct air capture has some potential. And of course, the other side of it is nature-based solutions, which is the idea of growing more forests and so forth. But I think we have to be really careful in that, because when you grow a forest, there's no guarantee that you absorb carbon dioxide in the medium to long term. How do you know the forest isn't going to be a forest fire in 20 years' time, or that in 30 years' time it's chopped down and used for firewood? I mean, we just don't know those things. But when you emit carbon dioxide, when you burn the fossil fuel in a plane or a car today, you're guaranteed to emit it and change the climate. So they're not the same thing, and they should not be interchanged. But that's not to say we shouldn't plant trees. We should be planting them for biodiversity reasons, for social reasons, not, I think, to allow us to live or to carry on burning more fossil fuels. And that's primarily what we're looking to do at the moment. So they're the sort of two technologies, BECCS and direct air, biomass energy with carbon capture and storage, and direct air capture, neither of which are anywhere in scale and have both come with big problems. And the other one's nature-based solutions, which is broadly about growing more plant material, particularly trees, and counting that carbon to allow us to carry on with fossil fuel use, which I think is a problem. So we need real mitigation, not these other alternatives.
Thank you, Johan, for your question. Do we have any more questions? Okay, so thank you so much, Kevin, for joining us and being and giving us this very, very crucial and interesting talk. It was very sobering, I must say, but I think it was necessary.